While the broad audience continues to perceive the artificial intelligence race as a competition of models and flashy presentations, in reality, the key battle is unfolding at a much deeper level, the level of silicon, architectures, and computing stacks. It is precisely here that one of the most intense and underestimated confrontations of our time is taking place, a technological duel between American leaders of the AI industry and China, which step by step is building its own alternative ecosystem. At the center of this process stands Huawei, a company that until recently was considered technologically cut off from advanced solutions, but which today increasingly appears in analytical reports as a real engineering competitor to Nvidia, albeit playing by different rules. The key mistake of the West, according to many technical analysts, was treating sanctions against Huawei as a final blow to its semiconductor ambitions. The logic was simple. Without access to advanced process nodes, without ASML lithography, and without the CUDA ecosystem, the company would not be able to create competitive AI chips. However, inside Huawei, a different conclusion was drawn. Sources claim that already in 2020 to 2021, the company made a strategic decision to abandon attempts at point-by-point catching up with Nvidia and instead build its own vertically integrated AI stack, from chip architectures to frameworks and data centers. This is how the Ascend line emerged, not as a direct clone of Western accelerators, but as a foundation for a Chinese AI ecosystem. The first Ascend 910 was essentially a proof of concept. It demonstrated that Huawei was capable of developing high-performance AI accelerators with its own Da Vinci architecture optimized for matrix operations and neural network workloads. On paper, it lagged behind Nvidia in a number of metrics, but within China, it was perceived differently, as a first step toward independence from Western hardware and software control. The real technological shift occurred after US sanctions were tightened, when deliveries of top-tier Nvidia GPUs to China were effectively halted. It was then that Huawei accelerated the development of Ascend 910B, a version adapted to production capabilities available domestically. It is important to understand that this chip was not worse by design, it was different in philosophy. Instead of maximum peak performance, Huawei bet on scalability, energy efficiency, and deep integration with its own MindSpore software. According to engineers familiar with the project, the key objective was to create a chip that could be deployed at scale in clusters, compensating for the lag of a single accelerator through quantity and optimization. This is where the most interesting technological aspect begins. Ascend 910C, which was actively reported on by Reuters and Asian publications, essentially became a modular evolution of this idea. It combines multiple compute blocks, increasing bandwidth and compute density while maintaining compatibility with the existing Chinese AI stack. For data centers, this means the ability to rapidly scale capacity without dependence on Western supply chains. According to analysts, this approach may prove critically important in the coming years, as AI models demand ever greater compute resources while access to top Western solutions remains constrained. At the same time, Huawei is addressing another fundamental challenge: software. Unlike Nvidia, which has been building the CUDA ecosystem for decades, Huawei is forced to create an alternative almost from scratch. MindSpore and related tools are still less mature, but their development is progressing at an unprecedented pace. Sources claim that Chinese universities and research centers receive direct incentives to migrate to Ascend-based cluster infrastructure, forming a new generation of engineers for whom Nvidia is no longer the default standard. Special attention is being paid by specialists to Huawei's future chips, Ascend 950 and subsequent generations. According to insiders, these solutions are already being designed with the experience of large-scale deployment of the 910 series in mind and are aimed at large language models, national AI systems, and industrial applications. This is not merely about increasing performance, but about deeper optimization for specific tasks, inference, training of specialized models, and distributed computing. In this sense, Huawei is moving in the same direction as Nvidia with Blackwell and the future Rubin architecture, but adjusted for its own constraints and priorities. The key question being discussed by technical experts today is not whether Huawei has caught up with Nvidia in absolute computing power, but how viable its strategy is in the long term. And here, opinions increasingly converge. China may not become the leader in the fastest chips in the world, but it is fully capable of creating an autonomous AI ecosystem sufficient for domestic needs and export to friendly countries. And in a world where AI is becoming infrastructure, this may be more than enough. Thus, the technological confrontation between Huawei and Western companies is not a linear race of gigaflops, but a clash of two approaches to AI development. One relies on maximum performance, advanced process nodes, and a global ecosystem, while the other focuses on scale, adaptation, and systemic independence. And if current trends persist, in the coming years, we will see not one, but two parallel AI realities, each with its own chips, software, and standards. And this, according to a growing number of analysts, is the main technological challenge for the West, not another release of a new GPU. Continuing this technological analysis, it is important to understand another point that often escapes even advanced tech channel audiences. The entire current discussion about whether Huawei is catching up with Nvidia too often boils down to comparing one chip with another, one process node with another, one teraflops figure with another. In reality, however, AI computing has already moved beyond single accelerators, and this is where the Chinese approach begins to look particularly dangerous for the Western model. Industry sources emphasize that Huawei is increasingly shifting its focus from individual chips to cluster architecture, networking interfaces, memory bandwidth, and software orchestration of computation. Simply put, the company is not building the fastest chip, but the most resilient AI machine, capable of operating for years without dependence on external suppliers. One of the key elements of this strategy is aggressive optimization for specific classes of tasks. Unlike universal GPUs, which must be equally effective across thousands of scenarios, the Ascend architecture is becoming increasingly specialized for workloads typical for China: state-level language models, video surveillance systems, industrial AI platforms, scientific computing, and large-scale applied inference. According to engineers familiar with internal testing, in such scenarios, Chinese Ascend-based clusters begin to close the gap with Western solutions not through raw performance, but by ensuring that every watt and every cycle is used strictly for its intended purpose. This represents a fundamental difference in design philosophy that could prove decisive in the long term. It is also worth addressing the manufacturing side of the equation. Despite obvious limitations in lithography, China is heavily investing in alternative ways to improve efficiency: multi-chip modules, advanced interconnects, memory packaging, and thermal optimization. Analysts note that whereas process node lag once automatically meant performance lag, today this gap is increasingly compensated through system-level design. This is why reports more frequently suggest that the race of nanometers is gradually giving way to a race of architectures and algorithms. Another important aspect is talent. According to sources, Huawei and related organizations are actively training a new type of engineer who works entirely within the Chinese AI stack, without dependence on Western tools. For these specialists, MindSpore, Ascend, and proprietary compilers become the norm, while CUDA is simply one external technology rather than an uncontested standard. In the long run, this creates an effect that is difficult to capture with benchmarks, but directly influences the speed of ecosystem development. As a result, more experts are concluding that the technological confrontation in AI is entering a new phase. It is no longer about who releases the next flagship chip faster. It is about who can build a closed, scalable, and reproducible system capable of supporting AI growth at the level of a state and an economy.